So hello, I'm Simon Dew, and yes, as Charles said, the presentation I'm going to give today grew out of my work as a technical writer at Stanley Black & Decker Innovations from 2006 to 2015. So this is very much from the pragmatic, practical side of things rather than the cutting-edge theoretical side. So a bit of background. As a technical writer, I had to produce and maintain user documentation, and each document might be published in dozens of different versions, so different brandings, different models of a product, different output formats, PDF, Windows, Help, whatever. And maintaining all of those different outputs is a pain in itself, but on top of this, each document had to be translated into, I don't know, about 10 different languages. And each of these documents, they might also have illustrations which required translation. So maintaining all those different output formats in different languages is even more of a pain. So happily, we were using XML file formats, DocBook for documentation, SVG for images, so we could use all the tricks like single sourcing, conditional processing, to handle the rebranding and the publication. But in this particular presentation, I'm going to talk about what we did to minimize the cost and effort involved in translation. So I'll just talk a little bit of background about the file formats that we chose to store the translations. We wanted an open source file format, and we considered two main standards, getText standard and the XLIF file format. Probably familiar with them. getText, commonly used for user interfaces in Unix-like operating systems, uses text files called portable objects to hold translation strings. XLIF, I feel like I hardly need to describe it now because Sarush and David covered it so well yesterday. But XML localization interchange file format. We ended up choosing the XLIF 1.2 file format because, first of all, commercial translation houses can use it very easily with their proprietary translation tools. And secondly, because it's XML based, it seems to make sense to us. We can integrate it with our documentation and our SVG images. So let's have a quick look at the traditional XLIF workflow. And if you've got to bear in mind this is all 1.2. If anything's changed in the 2.0 world, then I stand to be corrected. So first of all, the source document. It's converted into a skeleton file which contains the structure of the document, and then an XLIF file which contains the translation units themselves. And then this XLIF file is sent off to the translators who translate the source text to the required target languages. And then after translation, you have to combine the translated XLIF files with the skeleton file to create intermediate translated documents in each of the target languages. And then, of course, with our workflow, with the XML-based workflow, you then have to process these intermediate translated documents for the desired output formats. What this means is that the skeleton file and the intermediate translated documents all become resources which then have to be maintained. So, adding to my problems is that if you're publishing dozens of different versions of the documentation, you don't want to be maintaining all of those skeleton files and intermediate translated files. So, one solution to this would be to use what we could call dynamic translations and a different workflow. In this workflow, you would extract the translation strings from the source file, but you don't produce a skeleton file. Send the translated text to the translation text to the translators, and you get your translated text back, just as before. And then, when you publish the documents, your build tool, your build process has to take the structure from the source document and replace the translatable text with the corresponding translated strings. And the advantage of this is that you could then move elements around in the source document or delete them, and these structural changes are reflected automatically in your output documents without any need to regenerate skeleton files and that kind of thing. And this kind of workflow is already used with some getText workflows we were aware of. And so if you look at the paper in my references, I give an example of a build procedure for Mallard XML, which uses a dynamic translation workflow. So there were a couple of problems that we faced before we could adopt a dynamic translation workflow. First of all, we weren't aware of any solution which would enable it with XLIF files. And the bigger problem is that most of our documentation was what you might call modular. In other words, documents were built at publication time from several different source files which are transcluded into the main assembly document. And some of these source files might be stored remotely from the assembly document. So the problem is, how does your build process, your dynamic publication process, know where to find the correct translation for every single translatable element in the assembled document? So we designed a solution to these problems, and there's an overview of it there. And the design has three aspects. Within each of the source documents or source images, we used linked data markup to identify where the translation files for that document are. We also found that we needed, within each source document or image, we need some kind of markup on each translatable element to identify the correct translation within the exit file, the translation file. And then finally, we need a set of tools to handle this whole process, to handle translations as part of the overall document publication process. So just a quick look at a survey of some existing translation tools to see if they would be useful. I've already mentioned you can use getText for handling dynamic translations, but it's not aimed at XLIF files. It doesn't directly address the issue of modular documentation. We looked at ITS tool. It did provide some useful inspiration, particularly the use of ITS rules files, which I'll talk about in a moment. But it's aimed at getText, portable objects. Doesn't provide any help for modular documentation. And then, of course, there's the Okapi framework. Very useful for extracting XLIF files from a wide variety of formats. But again, we didn't find anything in there which is useful for dynamic translation or to address this issue of modular documentation. So we decided to spin our own tools to handle the translations. So I'm going to have a quick look at some of the design decisions we had to make. First of all, segmentation. Of course, this was mentioned yesterday in the XLIF talk. When you're extracting from the source documentation to XLIF, we need to, how are you going to align your source documentation to the translation units? So we decided to keep it simple. Our preparation tools, we need to determine what a translatable element is. So we ended up saying, okay, we'll define a reasonable set of elements for each of our supported file types as block elements. And each block element will map to a single translation unit. That's the simplest way we chose to do it. So for instance, in .book XML, a parallel element or a title element would be a block element, and they would map directly to a translation unit. And any child elements of that block element would be within text elements. And as you may know, the ITS Internationalization Tag Set 2.0 standard provides a mechanism for this. You can use the elements within text data category to determine which elements in a file are block elements and which are within text. So we decided we'd define an ITS rules file for the file formats that we use. And the XLIF preparation tools would have to use this ITS rules file to map elements in the source document to translation units in the XLIF file. That's a very short snippet from an ITS rules file there. Secondly, elements from foreign namespaces not permitted within the source text or the target text in the XLIF 1.2 file, so we needed to decide how to cope with inline elements in the XLIF file. And of course, this may all have changed. As I understand it, this is different in 2.0. We identified there were basically two different approaches we could take to represent them. We could use what we called raw, escaped inline markup, or what we call cooked or transformed inline markup, where the markup is transformed into XLIF elements, inline elements. And long story short, we decided to use the what we call the raw approach, the escaped markup for our inline markup for various reasons. But our translation houses prefer to work with cooked, transformed markup. So we had to write, as part of our tool set, we had to have a way of converting, round-tripping from one format to the other without losing any of the data. This all goes away in XF 2.0, but there you go, that's the way it works sometimes. Finally, DocBook, our primary documentation format, allows nested block elements. So, for instance, a para element could contain a footnote element, which could contain another para element. And XF is perfectly capable of handling this kind of thing. But just to keep, for the sake of simplicity, we decided not to implement this at first. Instead, we just decided to enforce a local writing convention that authors cannot nest translatable block elements. We also had a local writing convention, no translatable text in attributes. There's things that we could work on for the future, but we'll just avoid those for now. So, look at the implementation. We implemented this design as part of a broader document localization and publication project, which was known internally at Stanley Black & Decker as PackBook. That's how I'm going to refer to it here. It's been released. It's available under version 3 of the LGPL, and there's a repository on GitHub there. In this particular talk, I'm just going to talk about the parts of PackBook which implement this dynamic translation for XML documents. It does a lot more than that. There's full documentation on in the repository. So, okay, let's have a look at how we implemented the linked data part of the design. If you want to be able to translate an XML document, we need to add a translation statement to the metadata for that XML document. And we wanted to reuse existing vocabularies. So in the translation statement, we use terms from the bibliographic ontology, BIBO, and from the Vivo integrated semantic framework vocabulary. Now, of course, I may be misusing RDF XML here. I apologize in advance if that's so. But there's an example here of a translation statement for a DocBook file. And you'd add this to the info elements at the start of the document. You can see the Bibo document property says, okay, this file is a document, and this is the subject of the statement. Vivo has translation property, declares this document has translations associated with it. We've used XML base there to say where they are. And then the RDF, the list items say where each of the translation resources are. We use XML lang to mark the languages, and then the RDF resource marks the URI of the exit file for the translation in that language. And then for an SVG image, you'd do the same thing, but in the metadata element at the start of the image, you could use Vivo image as the subject of the translation statement. You don't have to, but now for a part of a file, you could have the translation statement. The easiest thing to do is to have the translation statement to do the metadata at the start of that particular part. So in a DocBook file, you could add a translation statement that only applies to a particular chapter by adding it to the info element at the start of that chapter. And this would, in our system, this overrides the translation statement at the start of the book. Now, if you transclude that chapter from another location, you can transclude its translation statements along with it. And this is how we dealt with the problem of translating document parts which have been transcluded from a remote location. So the other thing to say in this example, you can see we've used document part as the subject of the translation statement. Now I'll talk a little bit about how we implemented the markup part of the design. In the source documents, authors need to mark up translatable elements using a single attribute from the xlif namespace, the xlfid attribute. Not by hand. When I say markup, I mean automatically, but I'll come back to that in a moment. Now, the value of this attribute corresponds to the ID of a single unique translation unit in an xlif file. However, it doesn't have to be unique in the document that you're translating. We also use all of the local attributes from the ITS namespace in the source documents. So they're used as specified by the ITS 2.0 specification, so to mark up localization notes, terminology, and even to say whether a particular element should or shouldn't be translated. Why do we use XLFID? I mean, the ITS 2.0 recommendation stipulates that you should use XML ID. And the reason for that is that after transclusion, you could get the same translatable element occurring in more than one place in the document. So obviously, the two elements can't have the same XML ID. So here's a little snippet from a document showing the typical markup that we use for translatable elements in the document. And we had to create a custom extension to the DocBook 5 schema to allow the XLIF attributes and the ITS attributes. And this, there's an RNG file at the PacBook, the Stanley repository, which has those extensions in it. We didn't have to do that for SVG. We found that SVG already allows attributes in different namespaces. So yeah, you can see the XLFID file values are obviously automatically generated. I'll come back to that in a moment. So finally, in fact, here we go. We're going to look at the tools which we developed to handle the translations. So we implemented all of this using XSLT style sheets, all available on the repo on GitHub. I haven't got time to give a full description of them now, but I'll just give you a brief overview. But there is full documentation in GitHub. We can divide the style sheets into three groups. First of all, we have style sheets which enable authors to prepare the document for translation. So with these you can mark up the documents for translation, add the XLIF IDs, extract translatable elements to an XLIF file, create a differential XLIF file of new or changed elements, or patch new translations into an existing XLIF file. Secondly, we've got style sheets which translate your source document as part of your build process. So you can translate the document to a single target language, or if you want to create multilingual translations, there are extra style sheets which help with that. And then finally, we had style sheets for the management of XLIF files. So deduplicate translation units in an XLIF file, purge completed translation units from an XLIF file, round trip between escaped and unescaped inline markup, and a couple of import and export style sheets which I found useful. And we used Apache ants to do our document build process. The build scripts haven't been used as part of this project, so I can't give you a full description, but I'll tell you roughly how they worked. The build process would have to carry out the following steps for each document. Start with transclusion, so putting all the document modules into the assembly document. Then the translation step. Validation after translation. You have to validate after translation because the translated elements have inline markup. If there's any errors in the inline markup, that will become apparent at that step. And then conditional profiling, and then any final steps for publication. And then, of course, we also had separate build scripts to handle the translation of SVG images. And if we needed to convert the SVG files to a different format for publication, so PNG or whatever, then the image build scripts used Apache Batik, SVG rasterizer to do the conversion. I mean, of course, Apache Ant probably isn't the best solution. Probably an XProc pipeline would have been the best solution. I haven't implemented that. So, to conclude, I'll talk about some of the benefits of the solution, some of the issues that it had. It gives authors a great deal of freedom to create their own strategy for the EXIF files. You can have if you wanted to, you could have a single monolithic EXIF file for all of the translations across all of your projects, or you could have one for every single little bitty document, or anything in between. You'd have to find the right balance. And secondly, well, it vastly minimized the effort involved in translation. Far fewer files to maintain. The EXIF files that we produced, we could send them directly to our translation house without intervention. They could send their translated EXIF files back, and we could, with minimal effort, we could just drop them straight into the content management system, and they would be available straight away for translation. So the simplification of the process minimized translation errors, and also translation costs were reduced because we could share translations of common content more easily between several documents. Of course, there's a number of issues with this. I mean, you might be saying to yourself now at this point, Simon, where is the linked data? It says linked data in the title, and you haven't really used it. We're not making full use of it at all. This is a forward-facing solution. We were thinking of the future. There are, for instance, there might be ways of querying the document set to see translation coverage, how much of the documents require translation. There could be all kinds of solutions which would become available because we were using linked data in this way. We just haven't really explored all of that yet. And yeah, we were hoping to use linked data in our documents, not just to do with translations, all kinds of other things. I had big plans for linking it together with the products database in-house, that kind of thing. The whole system was designed for a DocBook and SVG as we use in-house, but it should be possible to adapt it for other systems, maybe data, maybe HTML5. I mean, you could easily mark up translatable elements with data attributes, but we haven't investigated how you'd mark up the linked translation data in HTML5. And then, of course, it's written, because it does date back a long way, the origins of this. It was written in XSLT 1.0 and because of eXSLT. And really, we would like to migrate this to XSLT 2 or 3. I think it would certainly make a lot of the code simpler. And the final issue, this solution is designed to work with what we call large-scale or context-free transclusion, i.e. transcluding chapters or chunks, big chunks of documents into an assembly document, and then it is translated after transclusion. Small scale, parameterized transclusion. Little example there, poses an entirely different set of linguistic problems which this particular paper does not address. But having said that, PacBook as a whole does attempt to address these linguistic problems. We have markup and style sheets which attempt to do that with some success, and you can see the GitHub repository for more information. So, to finish on a personal note, Stanley Black & Decker Innovations, the team which produced all this, was wound down at the end of July 2015, although I continue to do work for the parent company, Stanley. So, as it's open source, I've cloned the PacBook GitHub repository, so development on the project can continue, and I'd be very interested to collaborate, make contact with other people who are working in similar areas. So if you'd like to contribute, please get in touch. Okay, thank you very much.
Thank you, Simon. Do we have any questions?
For the modules in the documentation, are you using DocBook Assembly or have you looked at Dita?
We have looked at DocBook Assembly. I mean, we haven't started using it yet. Our assembly files are basically a huge collection of XI include elements, and we used we were using XSLT proc to do the transclusion step.
So is this not causing problems that you have different chunks for translation and different chunks for assembly, or is it the same?
Sorry, say that again, it's a bit quiet.
So do you have different chunks for translation in XLIF and different chunks for assembly, or is it the same?
The strategy for doing that is completely free, open to the document strategist with this solution. The way we did it was the XLIF files were arranged by project, more or less. So you have one project would have all of the translations for that project in a single file. The project might have lots and lots of different chunks. If any chunks were reused in a different project, then you'd have to have a statement saying, okay, by the translations for this chunk is over here and its translations are over here. Pull it all together, that's assembly time.
So did you use the ITS target pointer for it? Because this would be exactly the use case for it, you know, like the. What ITS categories you mentioned? Elements within text, translate, or did you use something else?
Yeah, we used translate. We used localization. The particular thing you're saying about target pointer is that assumes that there is, as I understand it, there is an attribute to point to, which will then be if I'm understanding you correctly. So perhaps XLF ID is not the ideal attribute to use to mark up in the source documents, but
well, I think the XLF ID is kind of necessary because because you cannot ensure the uniqueness, the global uniqueness of the XML ID. So I think you need to do that, and that's good for keeping the identity through the XLIF workflow, right? But I think that you could use the ITS target pointer for the assembly, because the XLIF is kind of the XLIF packages are project driven, but the assembly is design driven or display driven. So it's different.
Okay. Yeah, good point, Sam. Look at that.
Okay. Thank you very much, Simon. Okay, it's absolutely